cloud shader that I've been working on. And now, so before I was getting inconsistent results when going through the shell. So I had it working where like it would look good from above, and then it would look good from below. But when you would go into the shell, ah, lagging. When you would go into the shell, you would get like inconsistencies and some artifacting and stuff. I pretty much fixed that now. You can go through the clouds. The whole thing works. We still need to do some like additional Raleigh Mie stuff for the clouds themselves to give them some attenuation colors the same way as the atmosphere has it. Um, our light calculation is pretty naive right now, but that said, we are in a good spot to kind of start cleaning up the code for this now. So that's kind of my plan for today is to look into cleaning up the HLSL code, cleaning up the material, and then after that we will think about like some of the cloud lighting effects and such. But yeah, I'm pretty satisfied with this now. I was frustrated. Like I've been trying for probably 3 days to get the behavior consistent between going in the layer, under the layer, above the layer. And I ended up having to do a bunch of complicated shit to make it stay consistent. But it does seem to be working now. We're also not using too many samples here, which is nice. Um, I would like to figure out, if possible, a way to render this to a buffer and then blur it. Because we have to use this blue noise to hide the slicing. But you can see, like, when you get into, like, a low density area, the blue noise is really very obvious. If we could render the cloud layer output to a buffer, then we could blur it. But we can't blur it as it stands because you have to multi-sample. To blur the thing, you got to multi-sample it. To multi-sample it, we have to either have it rendered to a texture where we can just sample the texture a few times, which is doable, or we have to render multiple samples for each ray, which is not doable. That would increase its complexity by a lot. So eventually, I do want to see how I can render this out to a buffer and blur it. It'd be really easy if we were just in like a GLSL, but it's not. It's not as simple in Unreal, I don't think. I haven't found any good resources on it yet. But it's not the end of the world to have this stippling effect for now. It's better than nothing. And so let's get started. Gonna just be Worldscape. Worldscape. Yeah, I am. Uh, what about it? I am actually familiar with it. All right, so this is my shader. Let's make sure we have all of our inputs organized the way we want them. And we're just going to kind of go line by line through this. And when we're satisfied with a function, we'll downsize it until we're satisfied with all the functions. My planetary system is right. Okay, so if I remember right, let's look it up actually. Well, for one thing, it didn't cost me $400. I mean, this is nice. I don't know what kind of procedural generation they're doing. I am interested in looking at some of the clip map stuff. So I guess it's like right now not as good. Getting large and tiny, flat slash spherical. Smart terrain, noise-based biome system. Yeah, we have noise-based biomes. So like, yeah, it's not quite as good, or not quite as full featured. I guess we're not there yet, right? Right now, I just have atmosphere, clouds, planetary surface, biomes. I don't have foliage. I don't have oceans yet. So, you know, I'm not trying to compete with a product with a team of developers as a solo dev, though. All right. So let's finish cleaning up the code and the material. I get pretty satisfied with our sample for now. Remap should be fine. Ray sphere should be fine. Segment and ray structs should be fine. Okay. We're pretty sure our ray segments are fine. It should probably be named ray segments. Just to be a little bit more aligned with what it actually is doing. I think that our... This is the logic I had to beat my face on to get the clouds rendering properly. Calculate height coefficient. I think this is also fine. Okay, we're not using this. And we're not using the sigmoid function either. Don't think I ended up using this either. I love deleting code. It's great. All right. Let's review this. So this is our function that actually traces the cloud. To do light color slash accumulation slash attenuation, similar to the atmosphere for more realistic cloud colors. So what we've got right now is it's tracing the cloud colors that we feed it, and we can change these colors, but really the cloud color should be a derivative of the where it's at in the atmosphere, how much light is in that point. And we sort of do that by passing in like a base light when we trace the clouds so that they get darker as we go towards the night side. But it can be better. Like, for instance, all of this should be in shadow. But now that we've got our ray marching working properly, it shouldn't be too hard to add in the same kind of light accumulation stuff that we have in our atmosphere shader into the cloud shader. So we will continue. All right, so let's take a look here. Got a result. If our array that we're trying to process has a length less than or equal to 0, we just return immediately. Yeah, it might be. Right now my intent. So I have another. Basically, I'm working from the planet stuff is working bottom up. But I have another piece of this code base that is designed to be able to represent universe scale coordinate systems without having to load or anything and maintaining precision. And basically, what we're doing is abusing the relativistic relationship between um, distance, scale, and speed to where we can say render some galaxies in a particle system, and they could be arbitrarily far away from the camera, but we can scale their motion based on the player's motion. So, like, you're kind of treadmilling them along with the player to make them feel like they're far away. So, we can keep precision while representing like a huge coordinate space, right? And so, like, all this procedural shit for the planet is here with the intention of having things to populate at the lowest level. Like when you get to a star system, I would be able to spawn random planets and proceduralize them. And I could do this for every star in the galaxy. And then if you went to another galaxy, I could spawn in a new set of stars in the galaxy and it'd all be deterministic. So, like, this is kind of the bottom up stuff that I've been deep diving on. But I also have that kind of space engine esque framework for representing like a really large game world that I want to tie this into eventually. But yeah, if I get it to a point where I feel like it's competitive, then I would definitely think about putting out a plugin at that point. I don't think I would try to sell it for $400. But yeah. Okay, so results. We just immediately return if our ray segment has no length, saving processing. We check our ray direction. We check, okay, so this is a check to see if both of the line segment points are behind the camera. And if both the segment points are behind the camera, we immediately return and dump out. These are accumulation values. Ray position, our starting ray position for the ray we're tracing. Although actually, I don't need that. I can just always use array P1. Get rid of that. Step size is the segment length over the number of steps. That makes sense. Blue noise sample is a sample of a blue noise texture swapped into the negative 0.5 to 0.5 range and multiplied by our effect value. And then we modify our step size by that blue noise value. That makes sense. Loop through our steps. Calculate our current sample position. If our sample position is greater than the scene depth, that means it's behind an object, so we break. If our current position is behind the camera, it means that it's behind us, so we don't want to accumulate that value. Oh, and that was like a whole thing. It was like when I initially started this, right? Let's take a look at this paint drawing that I made. When I initially started this, I was using the camera position as the start of the ray tracing, which works but not very well. And the reason is as you move, your camera position shifts, which means all your slices shift, right? So what it ends up doing is you get this kind of zebra effect tracing through the clouds as you're moving the camera, where like because the camera's moving, your density samples are slightly different because you're sampling slightly different segments of the noise. So my solution to that I came up with was that rather than starting our sampling from the camera position, instead what we do, this is kind of an illustration. We have our planet here. our minimum cloud shell radius and our maximum cloud shell radius, and our camera position. So what we do is rather than casting the ray starting at the camera to the outer shell, we actually get the entire segment so that would intersect. So like for example, here we have our inner shell and our outer shell. The return from this is this segment and this segment, right? Even though this segment is behind the camera, we can cull that later. Or more, a better example would be like this one that's going forward, right? Instead of returning a segment from our camera position to this shell and then from this position to the outer shell, we actually backtrace to the outer shell, then all the way to this segment, then all the way to this second segment. And then our samples always start from our initial point, even if it's behind the camera. So our sample starts here, and then we step forward, and we just ignore the steps until they pass the camera. And then once they pass the camera, we start sampling the step density. And what that does is instead of making the slices dependent on the camera location, the slices are dependent upon the shell locations, which are static and they don't change. So that was like a whole thing figuring that out. What was this? This character movement component has received fantastic, reliable direction. Oh, that's cool. Pretty cool. That's something I'm gonna need as well. Oh yeah, I've actually looked at this one. Oh shit! They just gave it like baseline. Oh, that's amazing. That's amazing. So yeah, I may have to update to UE454. Then that's actually thanks for letting me know about that because I have gravity right here. Let's show that. I have gravity, but I don't have gravity for player movement. I just have gravity as like a force vector on the spaceship, right? Like you can see us move. Like this on the left is just me outputting our current velocity in kilometers per second, and you can see that we're moving even though I'm not moving, and that's because we're inside the gravity influence zone of the planet. So we're actually falling right now, but if I were to hop out of the ship on the surface of the planet, the character movement would be all fucked up because it's I haven't done anything on that yet. And I was planning on eventually doing that, but it sounds like they've just added native support for that in the next version of Unreal, which is huge for me. Pretty awesome, actually. We also have things like speed influence zones to pull us out of like warp like speeds into like planetary traveling speeds like you just saw there. So yeah, you can see the zones here actually. This is the gravity influence of the planet, this outer collision sphere, and this is the speed influence zone. So like when you cross this boundary, you get pulled out of whatever like interplanetary speed you're going into like the max speed that we want them to be able to fly on the surface of the planet. Um but yeah, that's huge, dude. Yeah, that's huge. It's freaking awesome. Oh, I'm excited about that now. Because as soon as wait, is UE554 out yet? So the only thing I'm worried about is I am using the real time mesh plugin. I've seen some people say they had some issues compiling with like the later 5.3 versions. Um, I'm not against trying it. I use the real time mesh plugin for my mesh chunk rendering. I just have it set on a very low depth right now because I was debugging the performance of the atmosphere without wanting the planet performance to get in the way. But like we can actually, where did it go? Here we go. We can actually change this to whatever we want. Let's try 13, which is very deep. So the procedural mesh component is not really fast enough to do this. So I'm using the real-time mesh component, which is a third-party plugin. for basically doing what we're doing right now. Um, but yeah, I'm quite interested in that gravity thing. That's pretty awesome, actually. I'll set it back to 6 layers because I don't really care about the surface detail of the planet right now. I'm working on the clouds. All right. Oh yeah, sick, dude. I made maybe tonight I'll look at updating my Unreal project and see if I can get it running with the real-time mesh plugin. If I can seamlessly upgrade to they're not enforcing substrate yet, are they? Like forcing you to use it? Because that would mean I would have to redesign all the materials, which would be a big pain. I know they had talked about eventually forcing substrate, which is fine. I think these. Okay, nice. Um, yeah, that's actually huge. Oh, I'm actually kind of excited about that because it would be really fun to be able to pop a third-person character on here and walk around on the planet. So we do have collision. Um, hopefully, it was working last time I tried it. Anyway, let's find out. Crash our ship into the surface. Oh, you know what? It's not going to work because I have it set on a certain depth. We got to turn the mesh planet depth up to do it. Let's do 10. 10 should be deep enough. And because we have to travel slowly when we're... Let's just go ahead and spawn it here. But yeah, so kind of my roadmap right now is I want to do oceans next after I finish the cloud stuff. And then I want to do some basic foliage stuff. Not necessarily spawning the assets themselves, but just being able to place objects where I want them in biome locations. And then there's like a whole deep dive to make procedural plants, you know? Yeah, we crashed. So we do have our collision still working and such. And we can actually sort of land on the planet. That also means that I can get rid of my existing gravity stuff, which is nice. Although I probably still want the influence zone. And it jitters around because I don't have the logic in there to stop applying the gravity force when it's flush with the ground or anything like that. But all right, there we go. So let's see here. Let's go ahead and continue the code cleanup. Make sure we remove any experimental shit that we had. Height coefficient. This is so we basically have a ramp up, ramp down to make the clouds like have thicker bottoms than tops, big butts, right? So we can give like I want the clouds to fade to zero in the bottom 20% of the height range, and I want the top to fade to zero in the top 60% of the height range, or something like that. And that's what this height coefficient does. Step density. Tidal density. That all makes sense. Light direction is the current sample position to the light. light step size is our cloud density steps divided by our cloud light steps. We have less light steps than our density steps, so we want to basically increase the magnitude of our step distance for the light samples times the step size. That makes sense. We loop through our light steps. We increment our light sample position. We sample our light density, multiply it by the total density and the light step size, increment it into our total light function, and then this function was just something I found in some GLSL um, for like basically doing the light calculations of the cloud. Return those. This ray struct rays, calculate ray segments. Yep. So this returns. This is the function that returns the rays that I illustrated here. So like this function basically cast rays. It's always going to return two rays, even if we only have one intersect. It will split the intersect in half so that we get consistent semi-consistent sample sizes in the segments, and also like we can always just process both rays instead of having to like, oh, do you have one ray? Okay, do one ray. Do you have the second ray? Okay, do that ray. We can just say do ray one, do ray two, done. Um, so basically, we calculate our ray segments. If we don't have any intersects, we just return nothing. We trace our first cloud segment. We append our second cloud segment data, and then we return the result. Okay, that makes sense. All right, and this is the atmosphere. At this point, we could probably get rid of some of the comments. Is this equivalent to... So this is code. This atmosphere code is code that I adapted from a GLSL MIT licensed shader I found on Shader Toy. Um, so I didn't write most of this. It's not entirely true. I've modified it heavily, but it's more commented out than normally I would do. Just because, like, usually you should be able to understand it. Oh, what's up, Scorpion? Yeah, we got them mostly done. I mean, I fixed the last bug that I was having this morning. So now you have a consistent, like, you see they're not flickering or anything. That was a bitch to get working. And then when you go in, you get consistent appearance going around it. It doesn't change. I still want to eventually render this cloud layer to a buffer or a render target and then blur it to get rid of the kind of stippling or the dithering basically that I'm having to do to hide the slices. You can kind of see when we get close to like a thin, like it starts to look really bad. So I want to be able to blur this, but that's actually more of a pain in the ass than it seems. But yeah, it's looking pretty good. We're just kind of cleaning up the code now. Okay, this is good. This is good. Calculate. Okay, that's fine. Trace clouds is fine. I want to compare this code to my existing ray sphere intersect function because we may be able to just... Oh, you know what? Okay. I already see one optimization we can make here. So right now we can change the center point of our cloud shell, but we can't change the center point of our atmosphere shell. It's because of this right here. This start position just being fed in without the translation here. So like this is the start position for our cloud ray sphere intersect. So we can probably fix that in our atmosphere by simply star position minus equals planet position, I think. If I just add that code, calculate ray properties. We don't need this in here at all. This is why we clean up, because initially I was trying to do the clouds in the same loop as the atmosphere. It just didn't pan out. The atmosphere slices are way bigger than the cloud slices, and you need a higher resolution slice on the cloud. You don't need a super high resolution slice on the atmosphere, just by the nature of the clouds being like a physical object that you can see in space, and the atmosphere just being like a color contribution. So I was trying to figure out a way to merge the two, right, and do them in the same loops. It just didn't work out super great. Um, you could there's also a huge optimization for the clouds and like a huge increase in cloud density by doing them between a shell rather than an entire sphere, because like think about the distance we have to travel here to here versus the distance of this entire ray, and then the fact that we have to divide the ray by our steps. It just made more sense to have them be separate functions. On the bright side, we don't have to have too many cloud samples anymore to get a good effect. So we fixed that. Okay, now, unless I miss my guess, we should be able to do this. Aha! Yes, indeed, we can shift the whole thing now. Great. So that fixes that. Now it should be easy to place our effect around our planets. That's a win. Yeah, and there's still some stuff I want to do. Like right now, the clouds are just alert between two colors. I want to integrate the atmosphere, the same kind of Raleigh Mie stuff that I'm doing in the atmosphere to get attenuation in the cloud colors as they go towards like the sunset side. Unfortunately, just multiplying it by the atmosphere color doesn't work because, like, for example, if I'm looking at this right, the clouds should be white, but or even here, the clouds should be white, and but the atmosphere color is like blue fading to like orange. And if I multiply that by the clouds, it actually looks really fucking good when you're in the clouds, because now the clouds should have the attenuation of the atmosphere attached to them. But if I'm out here, they should not, because we're outside the atmosphere, right? So like it's not as simple as just taking the atmosphere color and multiplying it by the cloud color. and washing your hands of it. We have to do a little bit more. But the actual tracing of the clouds themselves, their position in 3D space, the fact that they stay consistent depending on the view angle, like we have a consistent view angle. The shape stays the same. It doesn't like flicker in and out of different shapes or anything like that. The shapes don't change when the camera's moving. All of that stuff is good. Shift the position so that we can place our atmosphere at arbitrary locations instead of 0, 0, 0. All the racer intersects can be different depending on how they're calculated. I have the one I'm using for the clouds. I don't really want to fuck with this one right now. But let's leave a note. Eventually, it would be nice to come back and replace these inline race sphere intersects with our function. Not doing it yet because I'm scared I'll break it. Okay. Stop early if there's no intersect. Yes, yes, yes. That's fine. Calculate the ray length. That's fine. Ray nine. Okay, and this is all or shit. I guess I will just leave all the comments from the original code. Okay, we don't need any of this. This is part of like where I was trying to do the clouds in the same loop with the atmosphere and just decided against it. Yeah, actually, here I can show you. Mod atmosphere light plus. Yeah, here we go. So if instead of in the final scene, if instead of using the cloud color, I use this one, then I can show the kind of attenuation effect I was talking about. All right, you can see how it doesn't really look super correct from outside, right? Like you get this division here that looks really bad, but from inside, it actually looks really cool. Especially when you get into the like sunsets. It's actually quite nice. Um, I mean, I suppose I could just add a check to where if you're inside the inner shell, it does it, but it would still be a problem. So, yeah. For now, we'll just do the cloud color, and what we're going to end up doing probably is incorporating some of this logic into the cloud tracing as well. This up. Clean this up. Clean this up. Clean this up. Okay, sure. Main image, sure. And then we just initialize our constant. So another thing I figured out over the course of this is that there's a specific way you can author these things that will work with Unreal, and it's not the normal way that you would author these HLSL functions. Um, the problem is, conceptually, we are inside another function body when you do a custom node. So like when you put your code in this custom node in a material shader or in a material in Unreal 5 and you add your HLSL, you can envision this entire thing being wrapped by another function, which is a problem because we can't declare functions, right? Because we're already in a function, it won't let us declare regular functions the way you normally would. So what you have to do is like this hack workaround where you declare a struct, and this struct can contain your functions. And then when you want to use it, you can initialize that. You can initialize a copy of that struct and then invoke whatever function you want off of it and return that. And that does work. But for a while, I didn't know a good way to include global values in the struct because I didn't know that you could do it the way I'm doing it now, which meant that every function had to have every parameter that it would need passed into it. Well, I mean, it didn't, but I thought it did. That made it way more complicated to all of this because now, like something like atmosphere shattering is taking like 15 parameters in the function. Every time you use it, you have to make sure that every single parameter is in the right order, etc. But what you can actually do is just before you declare all your functions, declare all the constants that you intend to initialize externally. And then before you use the function off of your struct, you just have to make sure you set all the expected values from their passed in values that you create as inputs. Wait, what the fuck just... There it is. So like you can see here we have all these input names, and these names match the values here that we're assigning to our global parameters for our struct. If you do it that way, it's really nice because now I don't have a function with 20 arguments that I have to be sure that every time I use it, the arguments are ordered in the exact right order, and then every other function in the whole thing also has 20 arguments that all also have to be ordered in the right way. We can just set our global parameters and then use them, which is way, way, way cleaner and easier to like parse mentally. But look at this chonking. Look at this chonking custom node here. It's ridiculous. We don't need this opacity output. We can clean this up. So I think this is clean. Like, I don't think there's really any more changes I want to make to this code. So let's save it. Shit. And actually, let's propagate it to the one... I'll do that later. I need to propagate it to the one that I have in source control. Okay, so next let's clean up the material. This is a real mess. Alright, unconnected nodes get deleted. Light and planet position. We're going to make a new parameter group for those. This is our scene depth. We don't need to do anything with that. See, linear Scene depth. Housekeeping. Loud, light, color, cloud, dark, color, cloud parameters, cloud parameters. Great. What are these guys doing over here? Raleigh beta, MEA beta, absorption, ambient. These are all atmosphere parameters. Z, let's name the Z offset. It's a little bit more descriptive. Get rid of this. Do 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 do. Named reroute, hemisphere, radius. I like to do this when I have like derivative values, just so that like if I have to come back to this later, I will understand what the intent was there. Let's do like this and make it a little bit neater. Scattering coefficients. Let's set this to a baseline of like 0.02, 0.02, 0.02. Okay. Satisfying my OCD here. Light color and intensity can come over here as well. These should probably be actually shared parameters. Like we're not utilizing this light color yet in our cloud, but we probably should. So let's make this a shared parameter. Okay. Camera vector is just the camera vector. That should be pretty easy. Camera position is just the camera position. These do not require user being exposed to the user. Scene color is also just a derivative value that we don't really care about exposing to the user. Okay, cool. What just happened? Stop. There we go. All right, cloud colors are good. These are some more atmosphere parameters. Let's get these lined up. Yeah, so this morning I was like, I've been bashing my head on this problem for a couple days where like the the slices weren't consistent when the camera was moving. We fixed that by starting our array not at the camera but at whatever the further like the first intersection with the outer shell is, so that it's always starting from the same location. On that, if it's in that view orientation, the array will always start from the same position, so it'll always have the same step lengths. So all the slices will not jitter around as the camera moves. So that fixed that. But then I had this weird bug where it was incorrectly calculating the rays when you were inside in between the two shells. And I fixed that by breaking out the ray calculation stuff from being in one loop wrapped with another loop to in a separate function. And I think it was because I was accumulating the transmittance value over the course of both traces, which means that as you got to the end of the second trace, it would be like very close to zero. And I think that was the root cause of the bug, but it took me splitting that into a separate function to actually figure that out. But now it's working pretty well. All right, so atmosphere, 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 atmosphere. That's good. Shared, 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 shared. Let's change the name of this one to atmosphere density steps. Let's change our default value because this is way higher than we need. 32. Move this over here. Atmosphere light steps. 6 is probably plenty. World position's another derivative value. World position and pixel normal are actually both derivative values. Hey, Violet, you need help? I'll help. Come on up. You did it. Good girl. Ah, a little struggle bus. Okay. So I think that actually covers all of the atmosphere parameters. I would also like to figure out a way to get the scene color compositing outside of the function, but like for now it's fine, whatever. Okay, cloud parameters and lining up cloud parameters. It's another derivative parameter. Just this text coordinate, which in our case is a post-process material, so that's the basically the pixel, right? That's being traced for our fragment shader. Okay. ideally we get all these ordered the same way as well. Oh wait, nope. This is a atmosphere parameter. This is a vector parameter. I think I should be able to just do that. Should work, yeah. Okay, great. Mask was unnecessary here. Delete that. Move this over here. It's an atmosphere parameter. Great. Texture objects for our clouds. Oh, this was fun too. So there's actually in the engine textures, uh, there's this Perlin whirly balance. So normally to make cloud noise, you would take whirly noise, which is basically it's basically Voronoi ran through a filter. So like you take Voronoi noise, I think you subtract zero point 0.5 from it if it's 0 to 1, or if it's negative 1 to 1, you don't have to do that, and then you just absolute value it, and it gives you kind of this like fluffy texture, and then you combine it with Perlin noise, and that gives you like a cloud noise. But in the engine content, there's already a Perlin whirly balanced engine volumetric texture that you can use, which I believe is probably what they're using to drive their clouds as well. Um, so yeah, you can use that, and then you don't have to input multiple different types of noise to it. All right, this guy, this guy, this guy, and this guy can all just be adjacent. So we use these float fours to basically control our noise scales. So you could think of it as X, Y, Z scale modifiers, and then finally a weight for the intensity of the effect of that type of noise. So, like for example, we're running distortion with a strength of zero point 0.5. Our shape is a strength of 3. Our detail is a strength of 2, and our micro noise is a strength of 1. Um, and then those are summed up, and it's a weighted average, right? So like 3 times shape scale plus 2 times detailed scale plus 1 times micro scale divided by 6 is basically what the end effect of that would be. Um, okay, these are good. A little weird that I'm not seeing the clouds on this smaller iteration of it. What is my... We should need 6 steps here probably, but we'll leave it for now. Blue noise scale, darkness threshold, density floor. Interesting. So that's a little confusing. Violet, why do you keep jumping down when you have such a hard time getting back up? Oh my god. Here, here, here. Come on, come on. You can do it. Oh, careful. There you go. Oh, come on. Almost. You can do it. Yeah, you did it. Oh my god. She's blind, so like jumping up on the couch is a hard challenge for her. You did it, girl. You want a pet? You want a chin rub? Hey. Fight it. Come here. Get a chin rub. Alright, and then all of these should be cloud parameters. And all of these should be cloud parameters. And let's go ahead and convert to parameter cloud volume noise. Oops. Convert to parameter cloud blue noise. Okay, great. And these are going to be cloud parameters as well. Did you just unplug me, dude? Is that why my performance just dropped? Okay. Alright, now let's take a look at our material here. And we want to propagate in some default values here too. Is there a way... Hang on. Is there a way to quickly set the defaults in a material from a material instance UE5? I guess not. Alright, well then we just need to take what we've got here and set it up as our default. Unlock 0.5. Go through each of these. Okay, it's anything that's on the default can be unchecked here. This can't. So atmosphere height is one that can't be unchecked. Is this on default? Sure. G's default height absorption is default. Height ME is not default, but it should be default. Oh yeah, it's way too much. Oh, that's why. Okay, that's probably why our clouds aren't showing up in the material preview as well. Uh-huh. Height ME. Height 025. Height, yeah, height ME was 025. Height Raleigh was .04. 0.04, 0.025. Let's go ahead and turn off the preview scene. One, two, three, four, five. Okay, Raleigh beta is default right now. Scatter rate divisor is default right now. Skylight multiplier is default right now. Z offsets 0.075. 0.075. Okay. Save it up. Absorption for the clouds 0.005. Resetting this to default fucks it as expected. Okay, so 0.005. Point oh oh five. Transmittance was on like a 4. Aha! Now our clouds are showing up. Blue noise effect is at a 1. Blue noise, okay, it's fine. Um, no. Undo that. If I save this, now it's at the default. We can uncheck it. Cloud dark color, sure. Cloud density steps is fine. Light color should be fine. Light steps is on default. Okay, good. Darkness threshold is the default. Density fall off is the default. Density floor is the default. Oh, yikes. I fucked something up. Uh-oh. Yeah, so something got fucked up there. Hmm. Alright, hang on. Let's start undoing till we figure out what we changed that fucked that up. Ah, that's why. Okay, density 4 needs to be baseline 0.5. Okay, there's it. That's fine. expected. I fall off at a point 1. Lower cloud blend at a point 2 is the default. Max cloud radius. It's like controlling the height. I would like these to probably be relative rather than like hard coded radiuses. Okay. Transmittance needs to be 4. Okay. So now our only settings here that are not the defaults: atmosphere height, planet radius, max cloud radius, min cloud radius. That's it. So this is our default effect. It looks pretty good. Let's take the bird's eye view of our function. It at least looks a little bit cleaner. I mean, obviously, this giant fucking chunky custom function is a little bit intimidating, but it is what it is. Alright. Skybox. Why is my skybox off center? There. Save everything. Alright. I think we've got it polished up now. Let's do a little zoom into it. And we're zooming, 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 going very fast. And oh no, we're inside the planet. Shit. Hang on. Something is making this run pretty slow. Let's check our steps again. Our default cloud steps can probably be 32. If it lags and can't do the collision for the position, you can end up inside the planet, which is not ideal. Cloud density. Cloud light steps. Turn this down. That is substantially less iterations. Alright, let's zoom into the planet again and see if we can actually get caught by the speed influence zone this time. There we go. It pulled us out that time. The next thing that I'm gonna need to figure out is how to blur this shit, which it seemed like it would be pretty easy to just render this to a slab and then blur that slab, but I haven't found any good resources on it. Like I know how to blur the scene texture in a post process. What I don't know how to do is have a post process spit out some fucking color, put that in a buffer, and then blur that buffer because that's what we really need to get rid of the dithering effect on the clouds. You can also get rid of a lot of it with more samples, but we don't really want to have to do more samples. So like if I do 256, it runs slowly. Yeah, way, way too slow. But you should have less dithering up close. Let's do 128. You're still getting some dithering, but like the shade, let's go back down to 32. You can see the edges change, the edge fidelity. We'd like to be able to run like 16 and then blur this, right? Because if I could run a lot less samples, run a blur filter over this, it would still look good and it would be like way faster. But right now it seems like about 32 is the bare minimum. Do 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 do. So oceans are going to be coming up soon. Coming up with some way to get a reasonably decent water shader in place. I think we can maybe fit one more post process effect that's very simple, like because we'll need a post process effect for like the under the water effect. I think is how that's generally done. Like when you're intersecting it, you can render like the blue color under and sky color over. The other cool thing is that regardless of the camera distance, you can see that like our samples don't change. So like that's because our rays are constrained between the shells, which lets us get like density no matter how far away the camera is. You get the same number of samples. Although that's another optimization that we'll probably want to do for both the atmosphere and the clouds is some like distance away from the planet where we cut it down to a bare minimum number of samples because it would be like imperceptible at that distance, right? Flying through the clouds. Okay. I think I think that pretty much does it. Oh, I wanted to play around with this. Let's get up close. We have different textures we can use here. Blue noise scalar. Save it. It doesn't really, can't really tell the difference. High, high frequency. No, you see the slices with that. You can see the slices, which is the effect that we need the noise for. Is this kind of slicing. That's why we need the dithering. It looks like we can basically use any high frequency noise for the blue noise. It doesn't really matter. So we're just going to go to. We can fix all this as long as we can get the blurring in place. This is the one that I was using. Alright, I think the one that I was using is probably the best. Alright, and then. Okay, and then the other fun thing about this is. Okay, so right now, we just have one basic fluffy cloud shape, but because all the tracing logic and stuff is in place, if we really wanted to, we could implement our cloud noise texture however we want. So we could go out and say, okay, today we're gonna try to create a 3D noise texture that represents stratus cloud or strata clouds, and today we're gonna implement one that's cumulus, and then today we're gonna do one that's cumulonimbus, and then we could go combine those noises together and have different types of clouds composited, and like we don't have to change the rest of the shader. We only have to change the noise sampling function, which is really nice because that's like it goes from like, oh, I'm gonna have to spend, I guess it's probably been over a week now getting an HLSL shader to work, to I can just immediately go fuck with some noise textures and come up with different clouds, which is cool. So like in that spirit, what happens if we try some different noise textures? That one doesn't work. That one doesn't work. That one does work, however. We could feed it like a purling curl. It doesn't like it though because this can have negative values. So it's just all fucked up. Gradient turbulence. Ooh, that's not too bad. It seems like the best, though, is just the Pearl and Whirly combined. This is the one that gives us the best effect. To achieve this with the other noises, we would have to combine more than one noise texture, which means we have to do more samples, which is not really ideal. So using the existing like fully generated Pearl and Whirly, I think is the way to go. All right, well, big progress today. I think I'm gonna take a break, maybe play some video games, rest my brain a bit because this has been very grindy getting this working. And then maybe later tonight I'll start looking into ocean ideas. Later.